I'm just going to tell you some of the properties of the circle. If you have an arc of a circle, say here to here, and an equal arc here to here, perhaps that's L, that's the same, L, the angle at the center is going to be the same. The chord is also going to be the same. Say you have a segment of a circle, like so, and you make an angle with the middle. Say we call that X. Well, if you make another angle with a circumference, it doesn't matter where it is, it's going to be half of this angle. Let's try here to there. That's going to be half X. This is the same if you do any part of the circle. Perhaps here, half X. Perhaps here, half X. If you need to prove this in a circle geometry question, then you simply write angle at center is double angle at circumference. Similarly to that, if you have a segment, any angle going to the circumference is going to be exactly the same. So here and here. If that was theta, then that would also be theta. And any angle on the entire circumference is going to be the same. If you were proving a circle geometry question in an exam, you'd need to write angles in same segment are equal. One interesting phenomenon in a circle is the semicircle. If your segment was the entire semicircle, say this was the diameter, then the angle that you would form with any part of the circumference is always going to be the same, and it's always going to be 90 degrees. If it's here, if it's here, if it's here, and if it's there. Always 90 degrees. And in an exam, you would say angles of a semicircle. Right. If you have a chord of a circle, and your radius comes to a point where it touches perpendicular to this chord, perhaps like this. The next phenomenon of the circle is that this chord is bisected. Bisected. That means that it is cut in half equally. So that equals that. AB equals BC bisected by DB. Similarly, if you have two chords that are equal in length, their perpendicular distance from the center is also going to be equal. So those two lines will be equal. In the same way, two chords that are equidistant from the center will be of equal length. You would write this in your proof as chords equidistance from center are equal. Next, I'm going to talk about what happens if you put a quadrilateral into a circle. Here's my quadrilateral. Now, one thing that we know is that opposite angles are supplementary. So this angle here, A, and this angle here, B, are supplementary. Supplementary means that they equal 180 degrees. Supplementary. A plus B equals 180 degrees. The same with these angles here. C and D equal 180 degrees. This is called a cyclic quadrilateral. Now, any quadrilateral that has supplementary opposite angles is going to be cyclic. So if you find out that A plus B equals 180 degrees, then you will be able to draw a circle around your quadrilateral. So if these are supplementary, this line extended here will be C, obviously, because this is going to be 180 degrees. If you wanted to write about the supplementary angles in a cyclic quadrilateral in your exam to make a proof, then you would say A plus B equals 180 in brackets, opposite angles in cyclic quadrilateral. A tangent is a point on the very edge of the circle. It only just touches. The tangent, by definition, is perpendicular to the radius. Now, one interesting thing about the tangent is that another tangent sometimes will come into contact with it. Perhaps this tangent here. This line is always going to be equal to this line if it is between this point here, and the exterior point. So, say the exterior point A. And you can prove that if you need to do something in your circle geometry. Tangents to an exterior point are equal. Perhaps you could write that in your circle geometry proof. Now, if you have two circles and they just touch, there is going to be something interesting. First of all, they're going to share the same tangent. Perhaps this tangent here. Just one tangent that they will share. Also, since this point touches the tangent to the center at a right angle, it's going to also touch that center, also at a right angle, which means that this line is going to be a straight line. So you can draw a straight line between these two circles' centers, and they will touch through the point of contact, and you can use that as proof. The line of a tangent and this line just going to any point on the circle. This line here squared is going to equal this line here times this line here. So x squared will equal y squared times z squared. Also, if you have two chords, one here, this times this is going to equal this times this. So the main thing to remember with circle geometry is that there are lots of different rules that you can use, and you're never going to really know which one to use until you have a look at the question and just try and find out stuff. The more tools that you have, the easier it is going to be to answer those questions. And if you have any questions about circle geometry, please post them below. Thank you.